Here I have a cylinder, it's made of wood. Your cylinder would be made of coins. But the idea is still the same. I'll measure the diameter of the circular part. I'm getting 1.6 centimeters or 16 millimeters as the diameter. And I'll measure the height of the cylinder. It is 22.3 centimeters.
22.3 centimeters is the height.
Here's my data I'm using to calculate the volume. I need the radius, I need the height. Here's the formula for the volume of the cylinder. So I plug in my values and I solve for the volume in cubic centimeters. And here's my calculated volume. So now I'm trying to calculate the percent error I would get if I were off by 1 millimeter in my measurement of diameter. The actual diameter was 1.6 centimeters, but now I'm imagining I measured it at 1.5 centimeters, off by a millimeter. I calculate volume using this new measurement, and I get this as my answer. You can see there's a significant difference between my measured volume with the 1 millimeter error and the correctly calculated volume up here. Now I'll calculate a percent error. Here's the actual volume correctly measured. Here's the mismeasured volume. The error is the difference between them. So I subtract 5.4 cubic centimeters is the error. I now need to express this as a percent error. You will recall that percent error is the actual error divided by the value it should be. So in this case, it's 44.8 cubic centimeters is what it should be. This is my error divided by what it should be. Use a calculator. 5.4 divided by 44.8 equals. I see a 12% error. There it is, 12% error from a 1 millimeter error in measuring the diameter. I want you to also calculate what happens if you measure the height wrong. Here, I've imagined measuring the height poorly, and I recalculated the volume, and in this case, my percent error is very small. So I want you to do this with your coin data and see what you can learn from that.